Alright, physics. We got some stuff to go over. Back from break. I do hope that everyone had like a nice, restful, boring, or like, oh well, kind of boring, break. I did. I slept a bunch. I played too many video games. I ruined my sleep schedule. So, going back to work is jarring. Difficult to wake up early. But we're here. We're doing things. We're hanging out. These are the early midterm review questions. They're up. They went up as a thing. I was notified fairly early on in break, and I rarely check my email during break, so I'm glad that I saw this one. But someone had said, like, are the questions ever going to go up? Because the assignment's there, and there's nothing there. I was like, what? So, yeah. It was a smidge late going up, but it went up. The questions seemed to have gone up without a hitch. There were only a couple questions where I was like, ooh, that's a weird question that I haven't talked about yet, but I'm going to before the end of the break, or before the midterm. And I made note of them, and like when I go through and actually grade these, I'll take note of that. So I'm not gonna knock you guys for stuff that you wouldn't have been able to do without my help anyway. But let's get started. Let's take a look at these guys, and let's see how we're doing. Hopefully, you did okay on these. I just noticed something on my desk that was like super bothering me. So there's something that's like completely disorganized here. I'm just trying to put it back together. One take. I do this in one take. All right. So there were 20-something questions here. It might take a little bit to go through all of them. I apologize for like the length of this video in advance. I had thought about cutting it up, and I was like, yeah, we got to leave it all as one thing. So I'll try to go through this as quickly, but also as like thoroughly as I can. Starting here with number 1. Oh my goodness, what the heck? What was that about? All right, number 1. That is a little too. Let's do this. A 1 kilogram. Sorry, 1 kilogram. 1 times 10 to the 3rd, 1,000 kilogram car travels at a constant speed of 20 meters per second around a circular track. That is a giveaway for something. The diameter of the track is 1 times 10 squared, which is 100 meters. Magnitude of the centripetal acceleration. So that's AC equals V squared over R. I know that V is 20. I know that R is 50, right? Because 100 is the diameter, so 50 is the... Anyway, so that's 400 over 50, which is 8. It's 40 divided by 5, so that's 8. 8 meters per second squared. They all have the same units. There it is. Without air resistance, a kicked ball would reach a max height of 6.7 meters and land 38 meters away. With air resistance, the ball would travel... Well, without air resistance is how we kind of do all of our calculations, right? Magical Christmas Land. However, in real life, we have to deal with air resistance, which means all of our things are going to be slightly lower and slightly shorter, which means less than 38 meters horizontally and less than 6.7 meters vertically. Just be careful the order of those answers. That's the only tricky part of that question. Where's question 3? Hello? There it is. A car moves with a constant speed of 20 meters per second. What distance does it travel? In 2 minutes. Alright, the only weird thing here is that it's 120 seconds. Right? So velocity is displacement over time, which means that distance is v times t, which is 20 times 120, which is 2,400 meters. Choice D. Just be careful with the units. Make sure you convert to the appropriate units. Oh goodness. Okay. Lag. We're lagging. I don't know why we're lagging, but there we go. Okay. Shopping cart slows. So it slows down as it moves across a level floor. So energy, right? If it slows down, kinetic energy can't increase, it has to decrease. If it's a level floor, potential energy can't increase, so it must be choice C. Now this was the first question that I put a star next to, and the reason I did that is because we're looking for this here, right? And this term is not something that I think I've said before. I think I mentioned that the Newton's first law, which is an object in motion stays in motion, object at rest stays at rest, is like the law of inertia. But I don't recall if I ever said what inertia is. Inertia is mass. So if I'm looking for the greatest inertia, regardless of how long after starting from rest I'm looking at, I mean the greatest inertia is the greatest mass, that's choice D. So, just like an FYI, right? This is a side note. This is something that I will talk about a little more when we review a few more things, but inertia is another word, the formal term for like mass. It's the resistance to motion that an object possesses. So, it's mass. All right. Speaking of mass, we have a 3 kilogram mass thrown vertically upwards with a speed of 9.8 meters per second. What is the maximum height? So what's the distance? I know the acceleration is negative 9.81 meters per second squared. And if I'm looking for the height, I'm looking for the point at which it stops moving. So I have like an initial velocity, and the final velocity is going to be 0. So vf squared plus equals, sorry, vf squared equals vi squared plus 2a delta d. If you plug in these numbers, and you carry the 1 and you do all the math, you'll end up with choice B. Right. A 160 kilogram space vehicle travels along a straight line at a constant speed of 800 meters per second. That seems important. Constant speed. The magnitude of the net force. Right, if we're moving at a constant speed, acceleration equals 0, so the force equals 0. A 0.06 kilogram ball traveling 60 meters per second hits a concrete wall. What speed must a bullet have in order to hit the wall with the same magnitude of momentum? Alright, so P equals mv. I want them to be equally to each other. So m1v1 should equal m2v2. That means 0.06 times 60 should equal 0.01 times v2. Again, do the math, carry the 1, you get choice C. The reason I'm like skipping the math here is because the physics stops here. Right? This is the physics, recognizing that it's the momentum should be equal. After that, it's just math. Ooh, didn't want to move that. Want to move this. There we go. All right, this was another one. With the word impulse. Right? So impulse on your reference table is a capital J. It equals delta P, and it also equals F times T. Now one of those will come up later, but delta P is the change in momentum. I bring this up because as I read this question, it asks what is the change in momentum. They told me the impulse was 15, so change in momentum is 15. Right. This is something that when I go back, when I review momentum, I'm going to mention that like, oh, there are these other equations. It comes up very infrequently, and it's very direct. If you have to deal with impulse, it's going to be very direct. They will say impulse outright. Right. Hello? My computer is not being responsive. Thank you. My goodness. What quantities are scalar? So scalar are things without direction, no direction. So velocity and force are both out. Acceleration is out. Momentum is out. That only leaves one answer. Speed. Speed has no direction. Work actually has no direction. When we talk about work, and that's the last little loose end to tie up a little later this week, I'll explain why it's a scalar. It's related to energy. You should remember energy is a scalar. You have it or you don't. So work is also a scalar. You do it or you don't. Real quick, I'm going to try to figure out... No, I have no idea. Okay. 1.5 kilogram cart initially moves at 2 meters per second. It's brought to rest by a constant force in 0.3 seconds. What is the net force? Okay. So I know F equals m times A. I have m. That's 1.5. I don't have A, but I have V, which is 2. divided by 0.3, which is the time, so velocity divided by time. If I do that math, I get 10 newtons. Moving right along. A car traveling 15 meters per second north accelerates to 25 meters per second north in 4 seconds. Average acceleration, so Vf minus Vi over time. Well, that's 25 minus 15 over 4. Well, that's 2.5. That's 10 divided by 4. That's 2.5. What best represents the position of a ball as it falls freely from rest? So from rest means that it should cover a little bit of ground, and then a little bit more, and then a little bit more, so that's choice B. That's a much more common question than you would think. Yeah. The components of a 15 meter per second velocity at an angle of 60 degrees above the horizontal. So there's the horizontal, here's a 60-degree angle. I'm looking for this part and this part, knowing that this is 15. This is x, this is y. The x piece is going to be cosine, the y piece is going to be sine. You have an equation for this, you have equations for this. A cosine theta is x, a sine theta is y. If you do them out, horizontal should be 7.5, so it's choice B. Right. This is, can you break up vector components into their individual pieces? Do you remember how to do that? Right. Okay. Still trying to figure out like what is going on. It's fine. The vector diagram below shows, okay, so what is the part that's directed eastward? So again, I'm looking for, this is going up like this, and this is going over like this, so what is this piece? Right. So it's the opposite side. That's the sine. Right? Set up your angle. Set up your ratio, right? Sine theta is opposite over hypotenuse. I know that this velocity is 24 because they tell me it's 24 meters per second. And I know that this angle is 35, so I'm looking for the opposite side, right? I know that it's the sine of 35 should equal the opposite side, which I'm looking for, over 24. Again, I do the math, 24 times sine 35. I actually did this math already. 14 meters per second. That's choice A. Alright. 16 is one of my favorite questions on the entire practicing, and I'm pretty sure it's one that I've given to you before. Baseball bat exerts a force of magnitude F onto a ball. If the bat is 3 times the mass of the ball, then the force of the ball back onto the bat. For every action, equal and opposite reaction. The reason your hand hurts when you punch the wall is because it punches back with the exact same amount of force. It's choice A. Alright. Now I didn't know question 17 was going to do this to me, but like it just took up the whole page. It's a little bit of a weird question. Airplane travels north at 220 meters per second, and then but it hits a crosswind 50 meters per second to the east, right? What's the resultant speed of the plane? This means like what does the plane actually end up doing? Which way does the plane actually end up going? Well, the plane is trying to go up, but it's being pushed this way. 50 meters per second. So it's not going to be able to go straight up. It's actually going at this diagonal. And if I label this like this, you might see that I have a right triangle. And in order to find this side, it's Pythagorean Theorem. A squared plus b squared equals c squared. If you do the math, it ends up being c. I'll talk a little bit about that when we go backwards and talk about vectors again, but it's a little weird, it's a little strange. Again, it's like very niche, right? There's going to be like one question that might look like that on your midterm. All right. Getting into short answers, which are going to be a little difficult for the midterm, but I'm going to work it out in a way that works out. Calculate the magnitude of centripetal acceleration given that 12 meters per second and a 50 meters. Okay, so v squared over r. That's 12 squared over 50 That's 144 over 50, which is, give or take, again, I have this written down already, 2.88. 2.88 meters per second squared. All right. The direction of the velocity of the car. So where is it going as it goes around the circle? If it were suddenly not moving in a circle, you guys hopefully remember doing this, I'm spinning my hand around, right? The velocity is going to point directly to the left, or west, however you want to describe that. All right. Football is thrown at an angle. They tell us horizontal of 13, vertical of 7.5. I want total time in the air. Okay. If I need total time in the air, that's y information. So what is my y information? Well, I know that the y velocity, the initial velocity, is going to be 7.5 meters per second. I know the acceleration is negative 9.8 meters per second squared. Finding the total time is a little difficult, but finding the time to the top is not super difficult because I know at the top the final velocity is 0, and I can figure out how long that takes because I know that acceleration is final velocity minus initial velocity divided by time. So I can multiply both sides by time, then divide by acceleration. Time is final velocity minus initial velocity divided by acceleration, which means it's 0 minus 7.5 divided by negative 9.8, which is about 0.76. But that's to the top. I need to multiply it by 2, and that gives me 1.52 seconds. That's the total time in the air. Again, 0.76 was the time to the top, 1.52 is double. Alright, a baseball bat exerts an average force of 600 newtons. There's that word again, impulse. Like I said, J equals F times T. That's it. The J is 3.6. F is 600. Times t, which means I just need to divide both sides by 600, which means t equals, again, this math 0.006 seconds. All right, number 22 is a question. What is the average velocity from 6 seconds to 10 seconds. Well, this is a velocity graph, which is good. So between here and here, well, the average velocity is the only velocity. It's 15 meters per second. Done. Read the graph. Nailed it. What's the magnitude of the acceleration for the first 6 seconds? So from here to here. Well, acceleration is the slope of this. So 15 divided by 6 is 2.5 meters per second squared. The acceleration is 2.5 meters per second squared. Finally, what physical quantity is this shaded area? Right? What is represented by that gray section, this gray section up here? Well, area, right? If I was just taking the area of this rectangle over here, it would be base times height. That's velocity times time. I want you to think, what do I get if I multiply velocity and time? That's distance or displacement, whichever one kind of comes to mind first. But the area, right, the shaded area, the area under the curve for velocity is displacement. Just 2 more. Pluto orbits the sun. This is already going to be a gravity question. Calculate the gravitational force of attraction. This is the big gravity equation, G m1 m2 over r squared. Pluto and Charon. So I need the mass of Pluto. I need the mass of Charon. I actually don't know how to say that. It might be, I don't know. And then I need the distance they're separated by. So 6.67 times 10 to the negative 11th times 1.31 times 10 to the 22 times 1.55 times 10 to the 21 divided by 1.96 times 10 to the 7th. I gotta square that. I do all that math. So glad I did this already. I got 3.5 times 10 to the 18th. Newtons. When you calculate this, depending on what calculator you use, you might get like 3.5 E 18. That E just means times 10 to the. So if you're typing it out, times 10 to the. Finally, why is the sun's gravitational force on Pluto greater than the sun's gravitational force on Charon? More mass. Right. Pluto has more mass. And because the force of gravity depends on how much mass you have, if you have more mass, there's going to feel more gravity. Right? Now, if you have more questions, if something is still confusing, please bring it up. Email me, ask it in class, find me 10th period, find me during lunch, do something, all right? Please don't just sit there confused. Try to find me. Nothing official, right? No official work. But know that we are going to finish. We're going to tie up the last loose ends with energy, talking about work, talking about power. Then we'll start kind of reviewing in earnest. You will have a practice test, basically a test. It's going to be a practice midterm, kind of like end of next week, right? So just mentally plan for that. I want to do it before the Martin Luther King break. But yeah. I will see y'all soon enough, right? Until then, be good. Stay safe, kids.